Hi guys, welcome to the lesson Simplifying Surd Divisions. You may know what a surd is, don't worry, you soon will. So let's crack on and get the job done. A surd is the root of a number that cannot be expressed as a fraction. So root 2, root 3, root 8, those values cannot be expressed as a fraction, they're all surds. Square root of 4 is 2. That's not a surd. The square root of 9 is 3. That's not a surd. So if the root is a square root, then the square root of every number that's not a square number will be a surd. The square root of every number that's not a square number is a surd. Now roots obey the following rule, that the square root of a divided by the square root of b is a square root of the whole of a divided by b. So let's look at that with a numerical example. Root 100 divided by root 25, we are saying that is the square root of 100 divided by 25. Let's see. Well, the left-hand side, square root of 100 divided by square root of 25 would equal, on the right hand side, the square root of 4. Now the left hand side would be 10 divided by 5, and that is indeed 2. Therefore it does obey that rule. Let's look at fractions in surds. So we're going to be looking at the square root of. Here's our example. The square root of, and the fraction is 49/81. Now when the fraction is in the square root, you can apply the square root separately to the numerator and the denominator. So that would become the square root of 49 separate to the square root of 81. The square root of 49 is 7. The square root of 81 is 9. So that would be 7 9s. Similarly, the square root of that fraction, we can apply the square root separately to the numerator and then the square root separately to the denominator. So we would end up with that. Square root of 25 is 5. The square root of 16 is 4. So that's our answer. Similarly, apply the square root to the numerator and the denominator. Now this time those two numbers aren't nice square numbers, so it looks like we've come to a halt there, but we haven't, because we can simplify both these square roots. We can rewrite the square root of 27 as the square root of 9 times the square root of 3, and we can rewrite the square root of 45 as the square root of 9 times the square root of 5. There we can see it, and in the denominator, there we can see it. And in our fraction, we can cancel down the square roots of 9. So our final answer will be root 3 divided by root 5. So look out for those questions where you can simplify the surd further and then it may cancel down. Root 40 divided by root 5 is our sum, and the rule of surds tells us that that is the square root of 40 divided by 5. And 40 divided by 5, well, that's root 8. We can simplify root 8 as root 4 times root 2, and root 4 is 2, so our final answer is 2, root 2. So check out the steps. We put the two separate roots together because they're being divided. We can put them together in a single root, work out 40 divided by 5, and then look to simplify root 8. Here's example 2. Looking at the first example, we should be able to see our first step is to put the two numbers together inside the square root. And then 96 divided by 3, well, that's 32. So we're now looking at the square root of 32. You may remember up here, we looked to simplify our answer. We didn't stop at root 8, we simplified it. The question is, can we simplify root 32? Can we find a square number that goes into 32? And the biggest square number we can find is 16. And the square root of 16 is 4. So our answer is 4 root 2. Let's put all this together in a recap. A surd is a root of a number whose value cannot be expressed as a fraction, such as root 2, root 3, root 8. Really, you are looking for the square root of any number that is not a square number. Surds follow this rule that the square root of a divided by the square root of b equals the square root of a divided by b. So in this example here, root 48 divided by root 2, we can put 48 divided by 2 inside the square root. 48 divided by 2 is 24. And we don't stop there, we look to see if we can cancel down the answer. Can we find a square number that divides into 24? The answer to that is yes, we can. The biggest square number that divides into 24 is 4, so we can rewrite that as root 4 times root 6, and the square root of 4 is 2, so our final answer is 2 root 6. And in a fraction, which is inside a square root, we can apply the root to the numerator and denominator separately. So in this example, 16/25 is in the root. We can apply the square root to 16 and to 25 separately. The square root of 16 is 4. The square root of 25 is 5. So our final answer is 4/5. And if there's anything about the video you haven't understood, just watch it back. And if you have, that's great, because that's the job done.